Hello everyone. Today I'm going to introduction cryogenic pump or cryo pumps and their role in thin film fabrication. In thin film process, vacuum is very important. If the vacuum is not good or not, unwanted gas and contamination can affect the film quickly. Because of that, cryo pumps are widely used in advanced vacuum system. In this presentation, I will explain the basic idea of cryo pump, how they work, their main advantage, and how they are used in the thin film technology. And my presentation is divided into three parts. First, I will talk about the fundamental and principle of cryo pump. Second, I will introduce their performance and application. And finally, I will talk about recent advanced future trends and conclusion. So first, let's start with the fundamental and principles. And to understand cryo pumps, we first need to know why vacuum is important. And then we can see how cryo pumps are different from other type of vacuum pump. And in thin film process, vacuum technology is essential, and it helps create a clean and controlled environment for deposition. And this is very important for process such as sputtering, evaporation, and CVD. And if there are too many gas molecules in the chambers, they can clog with the dispersion atom, reduce film purity, and affect the film structure. So we need a pump system that can remove gas effectivity. And this is where cryo pumps become very useful. And a cryo pump have very high vacuum by trapping gas at very low temperature. It is especially good at removing water vapor and many other residue gas in the vacuum chamber. And in simple words, a cryo pump doesn't merely push gas out by machine code motion inside the vacuum space, and instead it frees or tap gas molecules on very cold surface. And this is the key idea of this pump. And before talking more about cryo pumps, let me briefly explain vacuum in thin film deposition. A good vacuum is important because it helps us control film purity, microstructure, and overall process stability. And a cleaner chamber means fewer unwanted reaction and less contamination. And in industry, there are several kinds of vacuum pumps. And for example, we have machine code pumps such as rotary vane pumps, scroll pump, and potion pumps. These are usually used for rural vacuum. And then we have turbo machine code pumps, which are used for high vacuum and ultra high vacuum. And we also have cryo pump, which are known for very clean and oil-free option. And compared with other pumps, cryo pump have a very important advantage, and they have no moving apart inside the vacuum side. So they create this lubrication and this contamination resists. And this makes them very suitable for semiconductor and thin film application. And now let's move to the working principle, which is the most important part. The basic principle of a cryo pump is cyclic condensation and absorption. And this means the pump removes gas by cooling internal surface to extremely low temperature. And when gas molecule touch this cold surface, they either condense or become adsorbed. And for example, gas like water vapor and nitrogen can be removed by condensation. And lighter gas like hydrogen and helium are hard to condense, so they are usually trapped by adsorption, and often on material like activity charcoal. And the cryo pump has three key parts. And the first is the flow head. This is a cooling source, and it usually uses helium gas in the refrigeration circle to reach very low temperature, often below 20 Kelvin. And the second part is the cryo panels, and they are the surface where gas are trapped, and different panels work at different temperature, so they can capture different type of gas. And the third part is the compressor, which circular and compress helium gas to drive the cooling system. And usually the pump has two main temperature stage. And the first stage is around 80 K, and it mildly traps water vapor at other gas with relatively high boiling points. And the second stage is around 10 to 20 K, and is used for lighter gas such as hydrogen, helium, and Nile. And okay, next page. And this slide shows the design and construction of a cycle pumps. Different parts use different material because each part has a different job. For example, the cold head often use oxygen-free copper because copper has very high thermal conductivity, and this helps transfer heat efficiency. The radiation shell often use aluminum alloy because it is lightweight and resistivity. And the vacuum chamber is usually made of stainless steel because it has good machine core strength and low outgassing. And for as a portion, material like activity, charcoal, or zeolites are used because they prove a large surface area for trapping light gas. Also, multi-layer insolution or NLI is used to reduce heat load and keep the system cold. So the design of the cryo pump is not only about cooling, and it is also about heat control, material choice, and efficient gas capture.
Now let's move to the performance and application for cryo pumps. Cryo pumps perform very well in high vacuum systems. They provide high pumping speeds for many gases and can reach ultra-high vacuum, often below 10 to the minus 9 torr. They are especially effective for condensable gases such as water, vapor, nitrogen, and oxygen. However, for some very light gases or noble gases, their performance can be weaker if the temperature is not low enough. One important limitation is regeneration after operating for some times. Typical gases built up inside the pumps, so the pump must be warmed up, cleaned, and cooled down again before the use. So cryo pump give clean and strong vacuum performance, but they need periodic regeneration. Cryo pumps are widely used in semiconductor and thin film process. They help maintain a cleaner vacuum environment during wafer processing. This means fewer particles, fewer defects, and better film quality. They are also used in PVD and CVD systems. In these systems, cryo pumps remove the residual gases and trap condensable byproducts, which improve process stability and the repeatability. So for thin film fabrication, cryo pumps are very useful because vacuum quality directly affects film purity and uniformity. Cryo pumps have several important advantages. First, they are oil-free, so the risk of contamination is low. Second, they can achieve very low pressure around 10 to the minus 8 to 10 to the minus 10 torr. However, they also have some limitation. They need periodic regeneration. The system is more complex, and the initial cost is higher. So their main strengths are clean operation and very high vacuum, while their main weaknesses are cost and regeneration. Next, I will verify introduce recent advanced and future trends. In recent years, cryo pump technology has continues to improve. Researchers are developing better solvent materials and better thermal design to improve gas capture efficiency and durability. Cryo pumps are also being better integrated with modern disposition systems such as PVD, CVD, and ALD. Some systems now include real-time monitoring and smarter control. These improvements make cryo pump more efficient and more suitable for advanced manufacturing. In the future, cryo pump technology will likely focus on 3 areas. The first is better materials for faster and stronger gas absorption. The second is improved cooling technology for low temperature and better regeneration. The third is better energy efficiency, so smarter thermal measurement and control system. These trends will help improve vacuum quality and the film production performance. To conclude, cryo pumps are very important in modern vacuum technology. They work by using very low temperature to condense and trap gases. Because of this, they can provide the clean and high vacuum needed for thin film process. They are widely used in semiconductor PVD and CVD systems because they offer low contamination and strong vacuum performance. Although they have some limitations such as high cost and the need for regeneration, they are still one of the best choices when vacuum cleanliness is critical. Thank you for listening.